everyone and welcome to our channel AKU Explanation. This is our part 5 of Matter in Our Surroundings, and I hope that before starting with this part you must have watched part 1 to 4. So in my last part, that is part 4, I taught you how we can convert how we can change solid to liquid and liquid to gas, that was melting and boiling and also condensation. Now in this part I'm going to start with latent heat, which is our first topic of this video. So what basically latent heat is? However, in the name heat is given, but this is not directly related to temperature. So latent heat is not directly related to temperature. So what latent heat is? So normally when heat is given to a substance, then its temperature rises. This, however, is not so when a change of state of substance takes place. That means when we are changing any substance to one state to another. That means, for example, just take, you have ice. Okay, this is a state of water which is solid. Ice. When you convert this ice to liquid, even though change of state of matter is taking place from solid to liquid, but there is no rise in temperature in the physical state of the substance. Yes, so this is what latent heat is actually. The heat energy which has to be supplied to change the state of a substance is called its latent heat. Heat, that means heat energy. Here I have written heat energy, not temperature. When you apply some kind of energy to this solid will get converted to liquid form. Again, when you apply some energy to this liquid is going to convert to its gaseous form. You have a solid ice. Okay, fine, this is ice. You increase the temperature. Okay, you increase the temperature. This ice is going to take this temperature in the form of heat energy, not directly as temperature, but in the form of heat energy, and this energy will cause this ice to change to the liquid form. So this energy is called the latent heat, to change the state of a substance from one to the another. Yes, so latent heat does not rise or increase the temperature. There is no increase in the temperature of the substance. This is ice. So this is ice is at 0 degrees Celsius. When this will be converted to its liquid form, this will be also at 0 degrees Celsius, because the temperature which you are applying here is not increasing the temperature of this substance, but this temperature is getting converted to the heat energy form, and this energy is able to convert ice or the solid to the liquid form. I hope you are understanding what I am saying. Now, latent latent means hidden. Yes, so in latent heat, latent means what? It means hidden. Why hidden? Because I told you that this energy, the temperature you are applying, but it is getting converted to heat energy. That means somewhere or the other the temperature is hidden. Now latent heat is of two types. One is your latent heat of fusion. Fusion, I told you in my last or some of my last videos that fusion means what? It means melting. Fusion or melting, they both are same words. So latent heat of fusion and latent heat of vaporization. What is latent heat of fusion? Here it is written that latent heat of fusion of a solid is the quantity of heat in joules. Remember, in joules. Joules is what? Joules is just SI unit of energy. Joule is SI unit of energy. Joule is SI unit of energy required to convert 1 kilogram of the solid to liquid without any change in temperature. Without any change. I am telling this sentence from the beginning of this topic. There is no change in temperature. Only energy is supplied. So when you have 1 kg of this solid, or this is your 1 kg when this 1 kg of solid is getting converted to liquid form, so the amount of energy which you need to apply on this solid is that energy will be called latent heat of fusion or latent heat of melting. Now our second point is latent heat of vaporization, or vaporization is also called as boiling. So the latent heat of vaporization of a liquid is the quantity of heat in joules. Again in joules. Joules is what? SI unit of energy required to convert 1 kg of the liquid to vapor or gas without any change in temperature. So here this, from solid to liquid, what it was called? It was called latent heat of what? This latent heat of fusion. Now when you have this 1 kg, you converted this solid to liquid, so this solid was 1 kg. So of course when this will become in liquid form, again this will be 1 kg only. Now you are going to convert this liquid to the gas. 1 kg of liquid is going to now convert it to gas. So now when this time, what amount of energy you are going to apply, that energy will be called as latent heat of vaporization or boiling. So I hope that you all understood what was latent heat and latent heat of fusion and latent heat of vaporization or boiling. Now moving to the next topic, this is sublimation. This is a very small topic and easy kind of a topic. You need not to take any tension regarding this topic. So we have already learned how we can change solid to liquid and liquid to gas and gas to liquid. Yes, and liquid to solid also. Solid to liquid you need to apply heat, and then liquid to gas, again you need to apply heat. Here you need to do the cooling process from gas to liquid. This was called condensation. Yes, then liquid to solid, again you need to cool the substance to reach the solid point. But how we can do this conversion? Directly from solid to gas or directly from gaseous to the solid state? How we can do this? So this process is called sublimation. When a substance is directly converted from its solid form to its liquid form without getting into the liquid form, from solid to gaseous form without getting into the liquid form, the substance will directly get converted to its solid to its gaseous form without entering the liquid form. That process is called as sublimation. See here, I have written solid. When you apply heat, it will be get converted to its gaseous form. Again, when gas will be cooled, it will form its solid form. So this whole process from solid to gas or from gas to solid, it is called as sublimation. Yes, okay. So here some examples are given. The common substances which undergoes sublimation are ammonium chloride, iodine, camphor, naphthalene, etc. You know what naphthalene is? Many a times your mother have put some white balls in boxes or in cupboards that are white in color, so that your clothes or something do not occur any fungus or any kind of like insects do not come there. So this naphthalene balls, their property, they are, you get these naphthalene balls in solid form in market, yes, in packets. But when you put these in cupboards or in boxes, they get directly converted to gaseous form, and after few months, like 1 or 2 months, when you will go to find these naphthalene boxes, you will not find these boxes because they have converted to their gaseous form without entering the liquid form. Now next topic is effect of change of pressure. That means how like what kind of effects do we see when we change the pressure? Either we increase the pressure or when we decrease the pressure, what kind of changes do we see? So we have already learned that the difference in various states of matter is due to the difference in the distances between the constituent particles. Listen carefully. The difference between the states of matter, that is, this is solid, then liquid, and the gases, it just because of the difference between the constituent distance between the constituent particles. In solids, the constituent particles, they are very close to each other. Yes, they are very close, so distance is very less, and that is why they are called rigid. So the distance is very less. Whereas in liquid, they are a bit far, but in gaseous they are very far from each other. So here the distance is very less, here the distance is moderate, and here the distance is very high. So due to this, what kind of changes do we see? Now just think that what will happen when we start putting pressure and compress a gas enclosed in a cylinder. Yes, you have a cylinder, just suppose, and you have a gas here. These are the particles of the gas, and you have a piston here. Now you apply force from above. You pull the piston downwards. So the gases of particles, they will come closer. Yes, the piston has now reached till here. Now the gases of particles have come closer. Again you apply more pressure. This time the gases of particles will be a lot more closer to each other. What will happen now? Applying pressure and reducing temperature can liquefy gas. Yes, when you apply pressure, a particular amount of pressure, and reducing temperature means the temperature is low. You are reducing the temperature. A gas can be liquefied. You can liquefy a gas when you increase the pressure and reduce the temperature. Yes, so have you heard of solid carbon dioxide? If you have not, just I'll tell you. Solid carbon dioxide. What is solid carbon dioxide? This solid carbon dioxide is stored at under high pressure, very high pressure. Yes. So solid CO2 gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is solid carbon dioxide. Just suppose that it is put in a container where pressure is very high. You have applied a lot of pressure from all directions. So this is in solid form. As soon as you decrease the pressure to 1 atmosphere, this solid will directly gets converted to gaseous CO2, because normally in atmosphere, what kind of CO2 do you get? Gaseous? Yes. In atmosphere we have gaseous CO2. Why? Because here in our atmosphere the pressure is not very high, but when you apply a lot of pressure or on this CO2, this CO2 will converted to solid CO2, and you need to apply this pressure constantly, because as soon as you decrease this pressure to 1 atmosphere, this solid CO2 will get converted to the gaseous CO2 form. So this is for our video. I hope that you will watch our 6th part also. That will be, I guess, our last part. So please like our channel. I will complete all the chapters as soon as possible and with a lot of your doubt clearance. Okay, so thank you very much, and like our channel, subscribe and share also.